This is number 16 from chapter 12. We're asked to conduct an ANOVA at an alpha level 0.05. So we have the raw scores here. There's some preliminary information that we can just get off right off the bat, like big N, for instance. Big N is just all the scores and the group's total. So we have 8 different scores per each group. There's 3 groups. So we have big N 24. We can also figure out the degrees of freedom off the bat as well. So degrees of freedom between, that's little k, or the number of groups, 3 groups, minus 1. So we have 3 minus 1 equals 2. Degrees of freedom within, that's the adding up all the degrees of freedom of each group, right? Each group. All right, so that's n minus 1 per group, right? So 8 minus 1, that's 7. So that's 7 plus 7 plus 7 equals, I'll put it down here, 21. With this information, we can figure out what the F critical value is that we're going to use to judge whether we should reject a null hypothesis or not. So the table works by finding the degrees of freedom of the numerator, or the degrees of freedom between on the top row, and degrees of freedom within on the side. So we have degrees of freedom on the top, 2, right? Little k minus 1. It was 3 minus 1, that's 2. And over here, we're going to have 21. So this goes to 18. And also, we're looking for the 0.05, right? So 0.05 level, that's the light phase, right? So that's the top number. So let's turn our page and get degrees of freedom 2 for the between. And here we want 21, right? So we have degrees of freedom 2 and 21. The light phase type is 3.47. So that's 3.47 is our critical value. So this is 3.47. Okay, so the first thing we want to do is kind of just start summing up these columns, and then we can also sum up the squared of these columns. For instance, this is, we want our first treatment squared. We also want our second treatment squared, and our third treatment, squared, not cubed. So this would be 25, 1, 4, 9, 0, 1, 4, 4. And this is 4, 36, 4, 9, 25, 9, 0, 9, 49, 9, 4, 16, 25, 4, 16, 25. Then we can just start adding them up. So make a little separation between what our answers are going to be. 5, 6, 7, 8, 16. So this is 16. And this one is, I pre-calculated these, 48. This is 24. This is 96. This is 32. And this is 148. So the first thing is to start with the sum of squares total, and then we'll partition that into the sum of squares between and within. So the sum of squares total, that is the sum of all of the scores and squared minus the grand total over big N. So this term here, we can get that just by adding the squares of each of these treatments, right? 48 plus 96 plus 148. So that term ends up being 292. So the G term, that is just adding up this, the raw scores before we squared them, right? So that's a 16 plus a 24 plus a 32. So that is 72. And big N, of course, is 24. Okay, so we get 292 minus 72 squared. Oops. So we get 76. Now we're going to find the sum of squares within, right? So the sum of squares within is adding up the sum of squares of each group. Okay, so we have everything we need, right? So we got to apply this formula here, minus the G, right? But the traditional sum of squares formula to each one of these groups. So let's start with this one. So sum of squares for that first group is 48 minus 16 squared over 8. Okay, so then that is 16. Okay, so then sum of squares for the second group is 96 minus 24 squared over 8. And that is 24. And then this one is, for the third group, 148 minus 32 squared over 8. That's 20. Okay, so then we have the sum of squares for each group. So then the sum of squares within is just adding up the ones for each group, right? So that ends up being, let me write a little barrier here. So this ends up being 16 plus 24 plus 20. So that equals 60. Okay, so then we have the sum of squares total, sum of squares within. So sum of squares between, that is sum of squares total minus sum of squares within. So our sum of squares total was 76 minus sum of squares within, 60. So we get 16. Okay, so now we have all the information that we need to do our mean squares, right? We can calculate mean squares, and then with those we can calculate the F statistic. So let's go over here and work on the mean squares between, and then we also have the mean squares within. All right, so this is sum of squares between over degrees of freedom between, and that is sum of squares between was 16, and degrees of freedom between over here, we said it was a 2, so it's 2, so that's 8. Okay, mean squares within, that's or sum of squares within, sorry, that's 60 over 21. Okay, so we have 60 over 21. 2.86. So then lastly, our F is mean squares between over mean squares within. So we have 8 divided by 2.86 equals 2.8. 2.8. Okay, so 2.8, and our F critical value was 3.47, right? So it doesn't go far enough. So our decision is to fail to reject the null hypothesis.